welcome to the lecture series on IC engines. We have already covered terminology, introduction and classification to some extent. This is the second part of presentation on classification of IC engine. In this presentation we will be talking of classification according to valve port design, according to valve location, fuel type, mixture preparation, type of ignition, charge stratification, and according to combustion chamber design, method of load control, and finally to types of cooling, operating cycle and working cycle. So let us start with our presentation. The first thing is according to valve/port design. You can see this first figure, poppet valve is there, in which the cam is pushing the push rod, which in turn moves the rocker mechanism, and rocker mechanism opens this valve. You can see this return valve. We have already seen the working of poppet valve in introduction to IC engine. The second type of valve is rotary valve. In the rotary valve, the opening comes in front of the port through which the charge is being sent inside the cylinder. Then the third one is the reed valve. Reed valve is used in the two-stroke engine, wherein the inlet charge is coming from this outer atmosphere into the crankcase, and from the crankcase it is transferred through the transfer port into this cylinder. So you can see this reed valve. The opening of the valve is opening of these flaps on the side of these valves. Next type of classification is according to valve location. Now according to valve location, the chambers, combustion chambers, that is the cylinder arrangement, is such that both the inlet and the exhaust valve, they are on the two sides of the cylinder. Hence the name T-head. So this is the T-head type, wherein one cylinder is on the, one valve is on the inlet side and the other valve on the exhaust side. Then we have L-head type cylinder, in which the inlet and exhaust valve, they are situated one behind the other, but on one side only. You can see here the head is straight one. It is say cross head, which is perpendicular to the side of the cylinder, whereas in the second diagram we have a dome shaped head. However, inlet valve and exhaust valve are same. They are located on one side, one behind the other. Then we have the I-head type. In I-head type, the valves are located on the top of the cylinder head, and they are again one behind the other, but they are at the center. They are situated at the center. So hence the name I-head type. Then finally we have F-head type, wherein exhaust valve is on the cylinder head and inlet valve is on the side of the cylinder. Then according to valve location, we also have one another classification, which we term as overhead valve and overhead cam. You can see here in the first diagram, here the cam shaft is located at the bottom, whereas valves are located at overhead this cam. So hence the name overhead valve. In the second figure you can see the opening and closing of the valve is done with the help of a cam, which is situated just over the valve. So hence this is called overhead cam. Here cam is situated over the valve, whereas in the first case the valves are situated over this cam. Then the third type is according to the type of fuel. So we have heard of petrol and diesel fuels. which are derived from the crude oil through refining processes. The other sources include coal, wood, tar sand, shale. So these all are fossil fuels which we use. Conventional fuels, these are called conventional fuels also. Then we have alternate fuels. In this it consists of CNG, compressed natural gas. Natural gas is the methane gas denoted by the symbol CH4. Then we have LPG, which is propane gas. It's a mixture of propane and butane. Around 50% both are there. So this is C3H8, butane is C4H10. Then we have biomass derived fuels. So these are derived from all the biomasses which are available. They can be vegetable biomass or the living biomass. We have this, under this category we have alcohols, methyl and ethyl alcohol or ethanol you might have heard. Then we have vegetable oils produced from the vegetable oil. Then producer gas is there. Producer gas is a fuel gas manufactured by blowing air and steam simultaneously through a coke or coal fire. Now producer gas, we include carbon dioxide, carbon monoxide, steam, moisture is there. Then in the biogas, it's a gas generated by the say byproduct of animals or human beings. Then we have the hydrogen, which is inflammable gas. So these are all the gases which can be used as alternate fuel. Then we also go in for blending of these alternate fuels with the conventional fuels. Like petrol is blended with ethanol to reduce emission. You can also have diesel blended with biodiesel, again to reduce emission. Then dual fueling vehicles are also there. Like we start with this petrol engine and then shift to either LPG or CNG. The next classification is according to the type of mixture preparation. Now in engines we need to produce the mixture so as to cause its combustion. Now mixture can be prepared either by carburation or by injecting the fuel into the air. Carburation is carried out in petrol or SI engines. So these include old cars, scooters, bikes, etc. Fuel injection is carried out in diesel engine as well as gasoline engines. Now in fuel injection we have various types. The first one is the manifold fuel injection or throttle injection. You can see this throttle is included here. Throttle valve is there through which the air is drawn by the engine and is sent into the say 4 number of cylinders which are shown here. So the air enters this manifold pipe and it is sent into the individual cylinders through this throttle valve. Now fuel is supplied by the injector from here so that it is uniformly distributed and it mixes with the air and is then distributed to all the 4 cylinders. The second is the port fuel injection. So in this, instead of spraying this fuel inside the manifold, fuel is sprayed into the port, one of the port where the valve is situated. So hence it is called port fuel injection. Fuel injector is there, electric connector is there, which will generate the spraying of this fuel injector. Airflow is coming from this side, it mixes with this fuel and is then entering into the cylinder. The third and last one is the direct fuel injection, wherein the fuel injector directly sprays the fuel into the cylinder. It is not spraying into the port, neither it is spraying in the manifold. It is directly spraying in the cylinder itself. Direct fuel injection. So DI engines, mostly you might have heard about the tractors working on DI engines. The next classification is according to the type of ignition. So ignition is carried out in case of SI engine by the spark, and in case of compression ignition by compression high temperature is obtained and the ignition temperature is reached. In spark ignition we have conventional methods, namely battery. It uses a battery and ignition coil to generate high voltage of spark. Then magneto uses a magneto. Magneto means a permanent magnet with a coil to generate the electricity. Other methods include electronic ignition. It uses sensors and ECU. ECU is a microprocessor which, depending upon the feedback from the sensor, it defines the precise time of sparking. Distributor-less ignition is there, wherein the need of mechanical distributor is eliminated. It uses multiple ignition coils controlled by ECU. Then the third one is capacitor discharge ignition. Energy is stored in the capacitor and it releases it rapidly to generate a high voltage spark. So in this manner, in SI engines, spark is generated. In the compression ignition, the ignition in the engine is in which necessary high temperature is produced by compressing the air in the cylinder before admission of the fuel. Next we will be talking of comparison of SI and CI engines. So first, on the basis of basic cycle. In SI engine, Otto cycle or constant volume heat addition cycle is used. We have already discussed Otto cycle and diesel cycle in the previous lectures. Then CI engines, it works on diesel cycle or constant pressure heat addition cycle. The fuel used in case of SI engine is gasoline, which is also called as petrol. It's a highly volatile fuel. You might have noted the vapors, say, flowing in the air when we move into the petrol stations. Self-ignition temperature of this fuel is quite high. So hence, we need a spark. It cannot ignite without the use of spark. You need to have a spark here. Then in diesel engine, it's a non-volatile fuel. You can see this non-volatility by just rubbing the fuel in between your fingers. Self-ignition temperature in case of diesel oil is low, hence by compression only we can reach the ignition temperature. Introduction of fuel. In SI engine, a gaseous mixture of fuel air is introduced during the suction stroke. A carburetor and an ignition systems are also necessary. Modern engines do have fuel injectors. So gasoline injection is also possible in modern engines. In CI engines, fuel is injected directly into the combustion chamber at high pressure at the end of the compression stroke. So hence because the high pressure is there, compression ratio is quite high, the temperatures encountered are also high. Hence they reach the ignition temperature of diesel. So hence, as the fuel is injected, it immediately burns. A fuel pump and injectors are necessary in this case. Load control. In SI engines, the throttle controls the quantity of fuel air mixture introduced. So when we press the accelerator, we are controlling the opening and closing of this throttle valve. So as we press more, the more quantity of fuel air mixture is introduced. However, the quality of fuel air mixture, it remains same. So hence this engine is also called quantity controlled engine. In case of diesel engine, the quantity of fuel is regulated. Air quantity is not controlled. It means to say we are just injecting, suction is taking place of the air directly into the engine without the use of any valve. So air comes inside and it is being compressed, and when we are accelerating, we are just controlling the quantity of fuel which we are sending into the engine. So hence this is called quality control. Why it is called quality control? Because as we press more accelerator, more fuel go into the same amount of air. So as we press less amount of accelerator, less fuel goes inside. So quality of fuel is being varied. Then next difference is on the basis of ignition. SI engine requires an ignition system with spark plug. Primary voltage is provided either by battery or magneto, or in recent cases electronic ignition is also possible by the use of ECU. In CI engine, self-ignition occurs due to high temperature of the air because of this high compression. Ignition system and spark plug, they are not required. Instead, we require the fuel injector. Compression ratio in case of SI engine is less, it is 6 to 12. Upper limit is fixed by the anti-knock quality of the fuel. If we go on increasing the compression ratio so as to reach the ignition temperature of the petrol, it will not be possible, because by increasing the temperature we are causing more knocking into the engine. Whereas in CI engines, the compression ratio can be as high as 16 to 22. And here the knocking will not take place by the increase in temperature. We will be discussing the knocking in the subsequent lectures. Upper limit is limited by the weight increase of the engine. So because you are having high compression ratio, you need to add more material. You need to increase the thickness of the cylinder so as to withstand high stresses developed by this high pressure. Then according to the speed of the engine, SI engines are lightweight, and also homogeneous combustion takes place because the mixture is prepared inside the carburetor, so they are high speed engines. Whereas CI engines, they are, due to their high compression ratio, they are heavyweight, and also due to their heterogeneous combustion, they are low speed engines. Thermal efficiency, on the basis of thermal efficiency, because of the lower compression ratio, the maximum value of thermal efficiency is low. And because you are having high compression ratio in the cylinder engine, so you can allow for compression to a greater extent. So the pressure generated, the power generated will be more in case of CI. Regarding the weight of the engine, SI engines is lighter due to the lower peak pressure, whereas CI engines, they are heavier due to high peak pressure. And this is so because again due to the higher compression ratio. Then we come on to the classification according to the charge stratification. Stratification literally meaning is grouping. Basically groups are formed. So these groups are of say rich mixture and leaner mixture. Richer mixtures, they are included in the vicinity of the spark plug, whereas the leaner mixture are spread throughout the cylinder. So hence, as the spark is generated, the richer mixture will burn first, and then the subsequently flame will travel throughout the leaner mixture to cause the complete combustion. So here again you can divide it into homogeneous charge, which is generated inside the carburetor. This is also known as pre-mixed charge. And second one is the stratified charge. This stratification can be introduced with the help of carburation also, or with the help of fuel injection. Next classification is according to the combustion chamber design. So you can see this first open chamber. In open chamber, what is there? We are having the single main chamber, in which the combustion takes place. So first diagram is shallow depth chamber. Here the shape of the piston is such that a very low amount of gap is there in between the head and the piston. So hence it is called shallow depth chamber. Similarly, we have hemispherical chamber in which the bowl is made inside the piston. So hence greater amount of space is given to the spraying of this fuel. Third one is the cylindrical chamber. Here cylindrical shape bowl is made onto the piston face. The next is the toroidal chamber. It is called toroidal because as it moves upward, a toroidal movement of the air takes place. So like spiral, it is moving in this circular fashion, which is called the toroidal movement. Then we have the divided chamber, in which initial combustion may take place in a different chamber and then it's spread into the main chamber. So we have for CI engine swirl chamber as well as pre-chamber. For SI engines we have compound vortex controlled combustion, CVCC. So it's a famous example of stratified charge engine using a divided chamber. Then swirl chamber and pre-chamber are also there in the SI engines. So all these chambers, they help the mixing of air with the fuel, because the diesel engine is injected not along with the air, it is injected separately. So hence we need to mix it with the air. That takes place in this divided chamber. You can have a look at this Ricardo swirl chamber, in which the air is coming and it is entering here and it is moving in a circular fashion, right? And when it moves in the circular fashion, then from this orifice it is entering into this. When the compression stroke is there, the air enters, move in this swirling fashion, burns, mixes with the fuel which is injected by this injector, and then burns here initially, and then the final combustion takes place inside the cylinder. Similarly, we have an example of pre-chamber, in which the fuel is injected from this nozzle and the air is entering through the cylinder into this pre-chamber. Air fuel mixes in the pre-chamber. Initial 20% burning takes place in the pre-chamber and rest 80% again is done in this main cylinder. The next classification is according to the method of load control. Now in load control, we can say the engine is running. Now if we are climbing a hill, you need to have a different mixture. If you are cruising at a constant speed, you need to have a different mixture. If you are overtaking, you need to have a different mixture. So that is how we control the load. So which mixture will be entered at what time? So that means the method of load control. Now load control in case of petrol engine, as I have already told, they are quantity governing. The strength or say the quality of the mixture, it remains same. Say we have a 15:1 ratio of the air fuel mixture. So that will remain the same. But the quantity of that mixture, that will vary according to the load which is required, whether it is cruising or climbing a hill or accelerating or simply idling. So this is used in carbureted engines where the carburetor is there. Then fuel control, that is by we will be varying the quantity of the fuel which we will be sending into the cylinder. So that is also called quality governing, and it is used in the CI engines. Here the pressing of accelerator will increase the amount of diesel going into the cylinder. Then the third is the combination. It uses both the throttling that is quantity burning and quality burning. The last one is the classification according to the type of cooling. So you can see in this figure, this is a engine of one motorcycle. So here fins are provided. These fins are provided to increase the surface area so that more heat is dissipated by the engine through these surfaces. So the air, it flows through this fin and carry away the heat. The movement of the vehicle causes the air to flow in between the spaces provided in these fins. The second, this cooling is called the direct air cooling. The second type of cooling is indirect air cooling. In indirect air cooling, the liquid coolant is used. This liquid coolant, it takes the heat from the cylinder and it brings it to the radiator. In the radiator, the fuel is dropped, the coolant is dropped dropwise, and as it comes down, it is cooled by the fan, which is powered through this crankshaft. So you can see this crankshaft with the pulley is powering this fan, and this fan is allowing the air to move through this radiator and takes away the heat from here. So these are the 4 cylinders wherein the coolant is moving around the water jacket provided around the cylinders. So you can see also this is the thermostat valve, which will decide when this valve going into the radiator will open. Like when it reach a particular temperature, higher temperature, so at that point the coolant will be injected into this radiator and radiator will remove its heat. So that is the end of this classification for now. We will be discussing in the next lecture the various parameters, including the efficiencies which are being used in the IC engines. Thank you.